Okay, 3.10, the normal distribution. So we already talked about how to use the 68, 95, 99.7 rule. And now we're going to talk about, well, what if it doesn't fall directly on a whole number away from the mean? This is where we need a chart or calculus, but we're not doing calculus because that's way too much fun. I can barely spell that word. We're going to use a chart instead. The copy of the chart can be found on Blackboard. It should be a button off to the left-hand side. Is this the left one, you guys? Because everything's reversed. I don't know. On the left-hand side, call the number below. No, whatever. You can use that guy. It's going to look a little bit different than what's in the video because I have an older chart, but how to read it is done exactly the same. There are two sides to this chart. You have a positive side and a negative side. In fact, let me load up this chart so you know what I'm talking about. So here is the chart. Notice a couple things. There is a side where the z-values is negative, and the other side, the z-values are positive. Make sure you are using the right side. Secondly, notice that the shading is always to the left. So here we're shading to the left. Here we're shading to the left. Okay, keep that in mind. That's what both sides have in common, along with how to read it. If your z-score was, for instance, negative 3.15, then you would need the negative 3.1 row and the 5/100ths column. So notice that would be 0.0008. And actually, now that I think about it, this chart is more accurate than the one that's in the video. We're going to go with this one. It'll be better. This one you'll be getting on your tests and everything because it's much easier to read, I think it is. So that's how you read it. So the leftmost column shows the whole number and the tenths place. And up top is the hundredths place. Now, as stated before, the chart only displays to the left. So if they were asking the question, what's the probability that a person's age is under or at most, you can read directly from the chart. If they ask, what's the probability that the person's age is greater than, at least, or between, then you have to make modifications to the chart. This is explained in the video. But basically the whole idea is, let me go back to my slide. Hi, slide. The whole idea is that, let me just make a curve. Oh, that's a horrible curve. Let's suppose they wanted you to find this. That shaded region will not be given to you on the chart. But what you can find instead is this portion, because it always tells you to the left. Well, just making this up, if you found from the chart that this part is 70%, and the whole thing has to add up to 100%, then what must this part be? 30%. So if you need to find at least or greater than, you subtract from 100%. Now, if you were asked to make between, this one's a little tricky. All right, I sort of redeemed myself there. Let's suppose we wanted this region. Well, again, the graph does not give you between. You have to make a modification. So instead, what you can do is, let me put some letters here. Let me say A and B. If you found the region less than B, and if you found the region less than A, so for instance, if you found out that 80% are less than B and 60% are less than A, and notice that A is contained within B, then how would you get between? You would just subtract them. You would do 80 minus 60%, or 20%. Again, those numbers were made up, but for demonstrative purposes only. So if they ask you for less than or at most, you read right from the chart. If they ask you for anything else, greater than or between, you have to do some form of subtraction to get the right answer. That's really about it. So if you would, please watch Finding Probabilities with the Normal Distribution. And as always, if you have questions, feel free to ask.